everyone. I am Azad ABBASI, co-founder and CEO of GeniusXR and Uverse. Today, what our focus is and what we do is we'd like to call it in one session, we have all the outputs needed. And we focused a lot on the digital human. We capture the humans and we could deliver meshes and point clouds. These assets are ready to go for games and cinematic. Uverse is one of our products. So we go from capturing, processing, editing, and post-production, a setup of at least 24 cameras, and we could go all the way to 200 cameras. So back in 2020, we partnered up with Sony and got into a venture deal with them to create a volumetric capture system. And in 2022, we opened the first studio open to R&D at the university level in Collège d'Alma. And finally, in 2024, we opened our own big lab. So this is the original dome with 75 cameras and 70 lights. And we have an area of 8 by 8 by 8 in feet of volume for capture. And currently in Montreal, we have the biggest volume for capturing, either mocap or volumetric. Our big area size now, which is for mocap, is 20 meters by 39 meters by 6 meters. It is huge. We also have a dome in there. Or we are partners with Sony, so currently we've been using a lot the RX02 for the last years. For this camera, for the price point, for R&D, for universities, is a very, very good option. We also have a full software, so a capture tool. So you do a fast frame process to see what one frame would look like. This part is photogrammetry or Gaussian splat. The big difference between photogrammetry and a 3D Gaussian splat is that we have splats now. Instead of having triangles where it's flat, we now have splats. We could have fuzziness. This is the future of content. Now, here we see a difference in quality, right? So we wanted to have 3D video. So we can't be in a tight circle capturing someone's face or their body. We actually need more space. And what that does is that it would reduce the quality. Base example here, it's a 8 by 8 by 8 volume space, meaning that this actor could move in an 8 by 8 space in feet. And the quality wasn't good. As you can see here, the photogrammetry looks okay, but it's not acceptable. Now in Gaussian splats, it looks very good and it is acceptable. Here we could see different qualities. From the dome, we could get previews, we could have game-ready content and cinematic content. From the capture, we are able to go to real-time or to cinema. One of them is rendered real-time in a game engine for games or VR and AR. And the other one is for lots of VFX, but it's technically to be rendered as an image or a video. What we were able to achieve was basically creating a 4D Gaussian splat. Now 4DGS technically means an animated sequence or an animation, a spatial video that you can move in and that is rendered real time. We capture in video, right? So it's synced video from 75 cameras. Then we will process it. So camera alignments, a point cloud, then the 3D Gaussian splat textures, splats, let's say. And from there, we have the finished product, which is a Gaussian splat, a PLY, that we will then edit and we will compress and we will publish. This here is one frame rendered from the studio, what splats look like, right? So this is a 3D version and it is on the web. This is on my browser. This works very well. And if I zoom in or here, you can see the actual splat. Let's see if we can, yes. So these are these splats. So this is what Gaussian splats look like. Now, what does an animated version of this look like? A compressed version that works on the web using our Uverse web viewer. So we can see here the same basketball player with the background cropped and animated. And this is a link that you can share. So technically, this is a spatial content is 4D video. And from here, basically, you can build any type of experience. It could be learning, it could be sports, it could be entertainment.